out of the first 8, you're going to choose
So
2.
out of the first 8, I must choose 2. Does that make sense?
Yes.
And this is the midterm review.
We need to get this now.
So, like the first, yes,
Okay.
yes.
No such thing as
Okay, mine's a little different, but I can put it together. Can't hurt that one. All right, so, yes, go ahead.
Are you gonna pick 2 that are like these?
No, I'm going to pick 2 that are right on the bloody thing. Yeah. So it behooves you to do them all.
Yeah.
You just walk in and boom. I told you where I was going to set this beforehand, right? Yes, Mr. Evans.
So will we be doing the trapezium rule?
Yes, we will. Okay, if I get to it today, if not, I'll get to it Monday.
Okay.
All right? And I have the notes and stuff in the back, and I have sample problems that have the answers. It can't get any easier.
So we're doing number 2 on this review sheet.
We will, no, we're not touching the review sheet today.
Okay.
Okay? I'm going to do Monday, Wednesday, Tuesday, Monday, Tuesday, Wednesday, okay?
Yes.
I want to go over an iteration because you're going to say like, oh, we did this, okay? And you see right away, if you go in the back or something, like, okay, let's just do this. Where it says Sammy's midterm. You see that?
Yeah.
And it goes a big fat meow. Okay, everything from that point forward, number 1 to whatever, 3 come from there.
Okay.
Makes sense. Now, number 1's a brain dead one. All right, it's like confidence interval. You have the formula sheet, everything else, and so on. I do like that number 6, and you probably like, well, we're gonna kill you to do that one, okay? So you can tell right away. I'm gonna definitely choose one from hypothesis testing, and I'm gonna choose one from iterations. Okay, make sense so far? And I think the last portion. Oh yeah, ooh, that's a good one. Then there's another part on the way back. It's a super duper Sammy Black Cat extra credit, yeah? You're going to see one of those or whatever of those as extra credit. It's okay? So the more you do, the more you're prepared. You walk in and go, hey, give me my 100. There's the midterm.
Yay.
Yeah, yay! You just got to work your butt off during this time, right? So, yes ma'am. So it makes sense? Okay. Any questions? All right. So we will continue on. I will also try to do the best I can with Mrs. You guys are really good with PDFs, right?
Yeah.
Partial becomes a fraction. Yeah, those, right? Oh, here we go.
Once I'll remember.
That's right. That's
So
like
are there
number.
any reviews on that, on this review sheet?
Are there any reviews on the review sheet?
That's all I forgot.
No, for partial fractions.
What is
It's
it?
there.
Yeah, if it's on the
It's
midterm,
there.
then it's on the review sheet.
Yes, it's there. And it's like number 2 and number 4 on the front. Okay, no problem. And then they got like for number 6, show whatever. Okay.
I'll learn that.
And number 8's another. You can automatically think to yourself, wow, Mrs. K was going bonkers on PDFs. Okay.
PFD.
PFDs, and they're like 5 points a pop and so on. Okay. All right. You know hypothesis is coming too.
Yeah.
You know an iteration. There's 3. Right? And then trapezium, I'm not leaning towards it, but I want you to be familiar how to do it. Because God forbid that I don't cover it, and it's on the test, and that's the only thing you need to get right. I didn't do my due diligence, okay? But I covered myself with all the notes and everything else, all right? So I won't lie to you, I really like on the bonus, I'm just helping you guys out here, I really like number 4.
On the
That's
extra
my-
credit?
Yeah, and the bonus. I'm sorry. It's super duper. It says extra credit.
No, but there are 2 4s on the back.
On the 2 4s on the back. Oh, thank you. I like the DNDT. It's the separation of variables. I really like that one.
Which one's that? Oh,
Number 4, during an experiment, the number of organisms, blah, blah, blah. It talks about, that's your first derivative and everything else.
Yes.
I just all warm and fuzzy. All right? Okay. Now, I want you to put this, yes, sir.
So then, besides the extra credit, you would like us to probably do all of the
All
problems?
of them.
okay.
Because all of them are fair game.
All of them. How many?
All.
One more?
All.
Thank you.
None of them.
We're not Bizarro World,
We all
okay?
know that.
You know that something's coming, okay?
Okay.
And it's all there. You can work together, whatever it is. Bug me at Starbucks if you see me or whatever, okay? But usually I'll tell you, just leave me alone. But, all right. So let's go to what we had before. And I had a request, all right, about the y equals the ln of x plus 1.
Yes, please.
Okay, so did we start it at all or no?
No.
Which one is
We
this?
left off
We
on
did that
the
E crazy one, right?
Yeah.
The crazy train to E. All right. It's right on the review, right?
Yeah,
Which one is it?
It's
One right under number
It's number 6, like the page before.
Yeah, there's two of them, right? It's either on the review, okay, and it's also in the packet of love I gave you about iterations.
Oh, the Ellen of us.
Yeah, I just love that one. Okay?
Which one?
Now, it doesn't mean I'll put it on there. I really like it, though. All right, here we go. So, the first thing, what we got to do?
Are you on
Well, we go number 6, right?
Oh, it's on
And it's like 2010 or whatever.
Yeah, May, June 2010.
Say it again. May, June
2010.
2010. That it? 61, 62, or whatever.
It's 33.
33.
It's number 6. Yeah. Oh.
That one
And
was
it's also number 6 on the review. Okay? All right, so it says, it wants you to do, what's the first eyeball? What's it say to do?
Show that the
It doesn't matter.
Yeah.
It doesn't matter.
Show that the x coordinate of this point satisfies the equation, and it's x equals x plus 1 over ln of x.
So it's y. Okay, so you get this one?
Yeah.
Yeah? All right. Right away, and there's a stationary point and everything else, right? It says something to that regard. So you see this one and go, okay. Most likely, I'm looking for a stationary point, saddle point, whatever it is, max, min. 1, you set it equal to 0, or you do this first. You take the first derivative, right? So you go dy dx. Voila. Now you guys know it's Lodi, Heidi, Heidi, Lodi, whatever.
yeah.
It's the quotient rule, UV. Okay, and if you didn't know, I'm just going to write the d of u over v is equal to uv. Now remember, you can switch these, right? V u prime over v squared. Okay, it's the derivative of quotient, right? So you guys already know your little limerick here, right? And this is u here, and that's v here. All right, here we go. Rock and roll. What's the bottom?
X plus 1.
Quantity squared.
Oh, yeah, bottom. Yeah.
Quantity squared. Okay, now what's the first one here? And we're going to put a minus right there. Yeah. You yeah. You want to do it that way? Okay.
X plus 1.
X plus 1.
Times
1 over X.
1 over x. Take the derivative of ln of x, it's 1 over x. All right? That's what they said, uv, right? Go ahead. It won't matter. It won't matter.
it'll swap if it's negative.
It'll swap it negative. It won't really matter because you're going to put a negative sign on the out.
Setting it equal to 0.
Yeah, exactly. Right? So, that's how they did it, right? And Emily, okay? Yeah? Okay. So now what's the next one?
ln of X.
Yeah, 1 times the ln of x, right?
Yeah.
All right, I like to put the little parts in there so you know what's going on.
Right.
All right. Here we go. Yeah. All right. Sam was busy last night. He was busy. And then now, Sam today, he talked to me, he texted me. He runs my minutes up all the time. I should just give him a Boost mobile phone, but that's another time. He said that I have to start working on the midterm. All right.
You pay my phone bill. I'm trying to get an iPhone, actually.
Yeah.
I'm trying to get an iPhone.
So, we set this out equal to what? Oh, actually, we can clean it up or whatever.
Set it to 0.
Set it to 0. Okay. Now, let's see if we can clean this thing up and so on.
X plus 1 over x.
Yeah. Yeah, okay. So I'm going to just rewrite this so you can see it. Minus just the ln of x. She's right. Of course, x plus 1 squared. Now, we got to solve for x or whatever it is, or prove something, etc. So the first thing is, let's see here. How'd they do this?
Eliminate the denominator.
Yeah, they distributed the x plus, they multiplied by the bottom, right?
And that cancels it out.
They just did this. Both sides.
Oh, yeah.
Goes away. You can. So this is going to be x plus 1 times 1 over x minus the ln of x.
Why don't we distribute the 1 over x?
Where I added the
Well,
ln.
why don't we just add the ln to the other side?
Yeah.
Well, yeah, but if we distribute the 1 over x, it'll
So,
cancel out the
okay,
x.
it doesn't matter. You'll get the same thing, right?
Yeah.
Yeah, so I'm just going to add the ln of x to both sides. That's okay. Method's a little different, but you'll get the same answer. So if the ln of x is equal to what?
X plus 1 times
X
1 over
plus
X.
1 over x.
Yeah.
Just to rewrite it, okay? Let's stop right there.
Are we times x?
Yeah, you just multiply it through.
Oh, you just.
I just put I made it easier, guys. I just moved that thing over to the other side. That's easier for me.
If you multiply the x,
If you multiply by x there, and then bring it over, then you're going to divide again. So, yeah, yes, sir.
And then we'll
You
just,
do the flippy flip.
yeah.
That's fine.
So we're gonna be
Yeah.
timesing by x and then dividing by ln x, and then
Yeah.
it'll give us what we want.
Yeah. Go ahead.
Okay,
It's
so
just an
what you
algebra.
have,
Okay.
you literally, so you're gonna divide by x, bring that over, and then you're gonna divide by ln x. And so
Yeah, you can do it that way.
Oh.
You can do it that way. I'm lazy.
What are we trying to get?
Oh, I don't know.
X equals
X equals
1
something,
over
right?
ln of x.
Yeah.
Which is exactly what we're doing.
Okay, so I have this right here, right? So I have ln of x is equal to x plus 1 x. Now what are we going to do here?
And we literally just flip-flop.
Flip-flop,
ln,
yeah, flip-flop, okay. Multiply both sides by x, because you want x by itself.
And then we divide by.
Yeah.
Yeah.
Oh, I thought there was some like weird math thing.
No.
That's
No, it's just algebra.
Basic algebra.
Well,
That's just
yeah.
basic algebra.
Did I do that right?
Yes.
Okay, thank
So
you.
now we just plug in, never mind.
Now we,
And
now
they
that's the
give
first
us-
part, right?
Now they give us the limits of,
Yeah, they give 3 and 4, right?
Yes.
So, okay. So, what they did, okay,
Area?
yeah. So far, are we okay here?
Mm-hmm.
Yeah, yeah, yeah. Can I erase this section here? Or
Yeah.
no?
It's on video.
No. Okay. She said no.
Okay.
I wrote 5 points.
Okay.
you can erase it.
She said no. Okay, good. All right, rock and roll. So here we go.
X is between 3 and 4.
Okay, so we had 3 and 4 things. So don't go bonkers yet, right? So what they did, all right, and I'm really lost on why they did this, but I think I know why. Minus the element. What they said, and I'm trying to figure this out. He said here, he said f of x, and this is where he plugged the points in, okay? He went x plus 1 over x minus the ln of x. That's what he did.
Oh,
Okay, and what are we doing there? To plug the points in, that's what he did.
okay.
Got it.
I think he just did a rearrangement. That's all he did.
Yeah,
Go ahead.
what he did was,
Yeah.
back when we had ln of x equal to x plus 1 over x,
Yes, Ellen.
he just brought the ln back over.
We brought the ln
Step
over.
before that was we brought the L in
Yeah.
the first place. If we look back at our work, we already have it written as 0 equals x plus 1 over x minus
We actually,
L of
yeah,
x.
we.
Oh, okay, it's already there, right? So this is the original or something, or
It's
whatever?
like,
No, that was halfway through our
That's
work.
halfway through.
that's after we
All
got
right.
rid of the denominator.
There you
That
go.
was just one of the
Okay.
steps.
Yep. Nick?
So what I did is I had x plus 1 over x ln of x minus 1.
Well, let's see if you're going to get the same thing when you plug in the points. Did you plug in the points, 3 and 4?
Yeah, and I got plus and minus.
You're fine.
Yeah.
You're fine. Okay? He had it written a different way. He got plus and minus. All right?
Oh, so 3 should be.
Yeah, here we go. F of
Okay, I
3.
see what we're doing.
Here we go.
All right.
3 plus 1 over 3 minus the ln of 3.
Okay.
Okay? We're going to test that thing, right?
Right.
Remember, I always draw. Oh, hold on, Kevin. 3 and 4, right? And we're saying if the root says hi to you, right? If the root exists. Remember, we're going between the values 3 and 4?
I'm just,
Go ahead.
how did we know to use that part?
Here.
Yes. Instead, like, why didn't we just, okay.
Why do we use this part? Why did I use this one? Why did he use this one?
Because it's not like you can plug it in and just do the thing.
She wants to know where did this come from.
I know that we got that somewhere, but how did we know to use that part?
Because it's
instead
equal to 0.
of-
Yeah.
So what?
Yeah.
Okay.
Ms. Aber? No? All right, so 3 here, right? And then you're going to get f of 3. Nick, what'd you get for 3?
For f of 3,
Yeah.
I got 0.214. Is
2,
that
3, 4? I got 2, 3, 4.
I got 2, 3, 4, 7, yeah.
Yeah, 7. So you just know it's positive, right?
Yeah.
Positive. It's greater than 0. Now we go f of 4, right?
Yeah.
4 plus 1 over 4 minus the ln of 4. And then this comes out to be obviously negative, which would become what value?
I got negative 0.098.
I didn't get that one, but
Yeah.
I got 1, 3. But you know it's negative, right?
Yeah.
What is that one thing?
Go ahead. Hold on.
When we're doing this, are we always going to use radians?
Oh, for natural log? No. Oh, good question. Natural log? No. You just use whatever they give you.
It doesn't matter.
If it's a cofunction, well, let's stay with, yeah. If it's a cofunction, yes, radians. Okay? It's cofunction, cosine, tangent, whatever, boom. Okay? Number, for whatever it says. Okay. Okay, there's a root. Good enough for government work there, right? Okay, now we do the easy peasy part, right?
Okay, I was using radians and that's how I got.
Oh, was it radians?
Yeah.
Why do they use radians? I don't know why they use
They
radians.
didn't, they weren't using radians, my calculator's on radians, and that's how I got.
That's
those
how they
two
got it?
numbers.
Why would
That's
they
how
always
I
use
got
radians?
those two numbers.
I don't know why they would use radians. Go ahead, Tommy.
It's between like a 3 and a 4, which is sort of the same.
Wait, why are radians relevant here?
Yeah.
LN is not
Yeah.
trigonometric.
Well, it didn't say that, go ahead.
Don't we only care
Emily?
about radians or degrees if it's a sine or cosine? Not
That's what I thought.
So radians is irrelevant.
Yeah.
Yeah,
Oh,
it's gonna get the same answer if you do degrees radians.
okay.
How do you do it?
All right. So if it's just 3 or okay, it's the same thing.
How do you not do it in radians is my question.
To me, radians is trigonometric.
Yeah, you're gonna get the same thing. So
It
doesn't
wouldn't
matter.
matter if it's.
All right, doesn't matter.
That's why I'm confused because
Yeah.
radians
Wait, what?
doesn't matter.
When you say radians to me, I mean I'm in the trig world. That's what I do. I'm in analytic geometry. That's with me.
Yeah, I don't think
Right.
radians come.
I guess it doesn't matter. But maybe they're. I don't know. I don't know why they say that, but that's
I think
it.
this is I.
Yeah, this is double I.
Versus, and the coordinates lie between 3 and 4.
Yeah, this is still eyeball.
So you
Oh,
plug
so
in the
first
3.
Still doing
Yeah.
the first one,
Yeah.
yeah.
Now the double I.
This is
Yeah,
still
it's
the
a
first
two-parter in a one-parter.
Yeah, where it says.
This is A, right? And then this part's B, right?
Underneath like the little formula looking thing, it says, and this,
All right.
and this.
So if you have an iteration, okay? Hold on. The first thing you do is do the prove. Prove or whatever, right?
Uh-huh.
The next thing is you do the test for the root. And the next one is you do the iteration. That's the x of n and x of n plus 1, okay?
Yeah.
That's what it's sometimes a 3-step, sometimes it's a 2-step. But if you follow that method, you're okay. All right? I know, sir. All right, here we go. Right? So we proved that jazz. Now I just have to write the thing here and then plug and chug, right?
Wait, I'm just understanding when
Yeah.
those numbers you're getting from like the little calculation, what do those mean?
If the signs are different, that means you have a root that exists between there.
Oh.
Change of sign means there's a root between.
So, but if they're the same side, then they.
Then there's no root. There's nothing that exists there. Okay.
So we don't really care about the number, but the stuff.
Plus, minus. Yeah. Who cares what the value is? Good.
If
Okay.
the root's the same, what does that mean? Like you
If
don't
no root exists.
Okay.
Okay. You prove that there's no root.
Okay.
Usually, if it's a money shot like a 3-point or whatever, you know that they're setting you up that there's something that's in between there. Okay.
So, the reason why this proves so is because you have to, if it's between 3 and 4, if the lower bound is, you're adding to it.
Yeah.
And if the upper bound you're subtracting from it, it
Yeah.
has to be in between.
Has to be between it.
Okay.
Okay.
So if it's both positive or both negative, it's not.
Correct.
Okay.
Does
Okay.
that mean somewhere in there is a 0?
Yeah.
Correct. It means it hits the axis, right?
Yeah.
Okay. That's calculus later. Okay. All right. So now this guy right here, right? So you got x to the n plus 1. This is your
So-
favorite part.
And then we use the lower bound, right?
Yeah, I use the lower one. It doesn't matter.
Okay.
It really won't. You can use 3 or 4. This situation, they use 4 because it'll start approaching that value that you round off to. Okay. It won't matter. I'm serious. It won't matter. Yes.
So like a rule of thumb for the future, do we use the
I use
lower?
the lower one.
Okay.
This guy used the higher one, and it won't matter
So
It won't matter. because it's going to approach that thing. Yes, ma'am.
So for the first part to the second part, what exactly is the answer?
Here.
Yeah.
Okay. This one would say just change a sign. Change a sign means there is a root between 3 and 4. 0. Okay? Intersect, whatever. Better? Okay. All right, now the easy part, so to speak, right? What do we have here? And then it's the ln of x to the n or something, right?
Yes.
Now, they chose 4. We can choose 3 if you want. You want to choose 3?
Yeah.
It's fine.
Why not?
Why not? All right, so that means that's x1. So x, 1 plus 1 is 2. That means it's going to be x of 1. 3 plus 1 over the ln of 3, right? And please tell me what you got.
3.6409.
Why is that again?
So far, so good?
Wait, why is that again? The
We're
X-
using this one, right?
Yeah.
We just chose it.
No, I mean the x of.
That's the
x plus
formula that
1
they gave us, right?
Equals.
X of n plus 1. Oh, did I do x of
Okay, you should just make that n a
X-
little
X of-
smaller.
plus 1?
That was
there
given.
you go.
That's what I meant to write.
It was just.
Why is it +1 and then what's with the L and the?
This is the subscript.
That's-
This tells me the number.
I know
Okay.
that. I'm saying, how did you get that fraction part again? What formula is that?
It was given
It was
to you in
given
the
to us.
problem.
Is it the problem?
Alright, it's in the problem.
It's like double I, right?
Well,
It says use that formula.
Use that thing.
Oh.
Okay.
As in, it was, I don't have the paper in front of me.
Oh,
That's my
okay.
thing.
That's what, I didn't miracle it yet.
Okay.
It's a mirror.
Tomorrow I walk
That's
above
it.
on water, right?
Thank you.
All right, so that's the first, 364, okay?
Yeah.
All right, let's do the next one. So now you're gonna use this guy here. This is your x2. So x3 equals 3.6409 plus 1 over the natural log of
3.6409.
3.6409.
So is the formula going to be different every time?
No, why would it be different? It will say, use this formula for the iteration process. Well, the formula, the method's the same, the formula, whatever they give you is different. Remember there was one with sine and cosine and whatever?
Yeah.
Yeah. Okay, what's this one?
3.5914.
Uh-oh, 3.5914.
Yeah.
Okay,
Why we do this one?
pardon me?
Okay, so what we're doing
Oh,
is
we
we're trying to find the
we're
exact
going-
number.
We're doing the thing we do, yes.
Number's gonna creep closer and closer to the answer the more we keep plugging it back into stuff.
We're doing what we did yesterday.
Yes, sir.
Yes. It's preferred. So.
3.5911.
Interesting.
Almost like that's the.
Want to do one more?
Yes.
Oh, what the heck. I'm just right, go ahead, Ems.
Because it says to 4 decimals.
Okay, sure. Well, I'm doing it to 4. They mean 4 here and then round to 2. Can they say that there?
Yeah.
Yeah.
What they're saying is, and carry out to 4, round to 2.
Yeah.
Okay? That's what they mean. All right, here we go. Next victim. Does this help at all? It's like a little loop. No, it does. Yeah.
It does.
Okay. Well, Jesus. x5, right? That value right there first, right? Because I got to generate x5. 5911 plus a 1. I just put parentheses there because that was weird.
Well, it would
Okay.
be 3.59 something.
3.5911 is what I got.
Again?
Yeah.
Okay, so that's our answer.
He's right. Oh, interesting. Now look for the pattern. Answer?
3.59.
Okay, now I'm going to play devil's advocate. They started with 3, okay?
Uh-huh.
They said 3, all right, for x of 1. So they're, just to play devil's advocate, they're like, well, which one do I use? I'm freaking out. No, okay? When they did 3, or they did 4. Sorry, I'm reading what we did. When they did 4, their first one there was 3.6067. Then, guess what it did? 3.5911, 3.5911. You get the idea, okay?
Where did we get the 3 from?
Magic.
Very good.
It told
Okay,
us
it says the bounds are 3 and 4.
3 and
so
4.
We just chose
So
one.
if you choose either, you're okay.
Oh, see, but you're not going to know which one's the closer one, so it doesn't really matter which
Doesn't
one
matter.
we're going to do.
It's going to approach, it's going to sandwich that thing in there.
If we would have picked 4, is
You-
4 x of 2 or no?
Yeah, well, this would be x1. That's what you start with, right?
Oh, it's
This
okay.
is your, remember, let's call this the lower bound and the upper bound. So it says between 3 and 4, right? He's exists in there somewhere. Where am I? Right? You don't know where he is.
So he's at 3.
He's in there somewhere. Well, 3, 6, well, you don't stop there. Remember Robert Saffron? Daffron, thank you. Well, he wants to
He's a
stop right
spice.
there. I said, don't be fast and furious like Robert. You know, you keep going until you see it start doing repeats.
Okay.
Okay?
So if
You
there's,
just, because it iterates.
Ah.
if there's no root, then you can't do that, right?
Right. I'd give you the root because I'm just a warm and fuzzy person. What they did last time, didn't we do something like this? I can't remember. I did it in the other class. They had something right here, pi and 2 pi.
Yeah.
And so you can choose between, now it's radians, right?
Yeah.
So then you go 3.14 here and 6.28.
Yes.
Okay?
It's cow.
So you use either one of them. And it doesn't, Sophia's like, I like the bigger one. No problems. You use 6.8. Well, and Sam says he uses that one. It doesn't matter. It's going to converge to that 0.
Yeah.
But also, when we did it, they used 4. So are we allowed to use any of the numbers?
You can use it. Doesn't matter. You know why? All they want you to do, this is what they're going to grade you big on. Did you get this guy right here? Did you show the convergence of that value? Good question. It doesn't matter which one. It doesn't matter. Now, if they give you, well, x1 is 3, boom,
Use
okay,
X1.
okay.
As long as they give you.
All right, any questions on iteration? Should we do another one? Do you feel confident with this one? I know you feel, I know that. Mr. Epler.
So could you do
I'll try.
May, June 2014, number 6?
May, June 2014. Oh, he's way up there, okay?
The I part I had trouble with.
Okay, so he's going. If you notice that some of these are also in the review, okay? All right? All
Oh,
right,
that's
so.
a funny one.
I did like the May, June 2013. You'll see that on the review for the iteration, okay? You'll see it. So you just do one or two of these and then you're pretty good, okay? All right, so Mr. Upper asked for,
May, June 2014, number 6.
oh, that monster, okay?
It doesn't look too bad.
Don't worry about the picture. Now, the biggest thing is, I excluded this because you had to do a little bit of trig on it, okay? I will not ask this on the midterm.
Okay.
Because I talked to Mrs. K about this, and she's like, well, they haven't seen or been exposed to, like the shaded region and everything else.
Yes, we have.
Oh, well, okay.
That was like last year.
That was last year. That's arc length and
Kind of
everything.
shaded information.
Well, I'm saying that they do this, it's called the perimeter of the shaded region, and then you have to get the radius. Okay, that's what they did.
Yeah.
If you're that interested, I can do it, or I could do some, okay. If, Nick, you
Yeah.
can take a picture of the answer, okay?
Okay.
How to do it. And if you want, see the class, and I'll show you. All right, anything else?
Can we do one of ones, other ones from the review?
Do it, I
Yeah,
didn't, like, there's no mention on the
Which one is it, the X, I can't remember.
Yeah, just do the one after 6.
Oh,
Is it on the midterm?
Yeah.
Review?
Number 2.
Yeah, number 2.
Oh, hold on, let's see.
is that also
It's
in
on the
this?
Sammy version, right?
Yeah.
I'm not sure. It
Yeah,
might,
it is.
Okay, Sammy,
it
yeah.
looks like this.
It's like the X
so-
and of
Oh,
1.
not that one,
Number
okay.
Number 2.
Hold on.
It's on like the page before the last.
Okay, hold on, let me get
Front
my
and back.
ducks in a row here, okay? So to speak. Okay, that's the copy version.
Yeah.
This one?
Number 2.
Hold on. So I know exactly,
might
because
be
I had to
under
make a
somewhere.
review answer sheet too, right? So yeah, it never ended. Oh, there's the Sammy review. Oh, here it is. Ooh, I went really nuts with the confidence stuff.
Yeah.
The stat stuff. Okay,
number
so here, I'm still going. All right, we did number 6, right? I'm still going on here. All right, I'm still looking. All right, I'm still going. Is it number 2?
Yeah.
Yes, oh no. Is it x to the n plus 1 equals x to the n
Yeah.
times parentheses x n cubed, whatever?
Yeah.
Yeah, okay.
Where am I now?
They're going, okay,
You.
they're going on the review packet.
It's May, June 2013.
May, June 2013.
Okay.
Either one. If it's on there, you know it's fair game. The review packet's view in the back. All right.
May, June 2013, number 3.
I think so, right? Yeah.
Yeah.
And I'll put that on there, hold on. So you know where I got it. And I had another packet, October, November, but I thought it was just too overwhelming. So, yeah.
October, November is always harder.
Yeah, but you know, math is the toughest class. Sorry, my bias. Math and science are the toughest classes. You're going to experience that, and you'll be fine. So, May, June, what? 2000 what?
13.
Any 30, 35, 39, or
32.
32. Okay, and it's also number 2 on the Sammy packet, right?
Yeah.
Sammy review, meow, review.
And also number 2 on the iterations packet.
Yep. That's there, here. Yes, good job. Okay? All right. So it gives you the conversion value already, right? It converges at that alpha. Use the formula to calculate alphas, whatever. Okay? Looks like, guys, all they care about is to do the first iteration, right?
Okay.
Okay? So let me copy this down. Now, are you guys okay with me doing this teacher-driven stuff, or you want me to sit in the back and walk around?
Let's just do this
No,
one and
yeah.
then
You want to try it?
No. Just do it with
there's a lot of stuff going on.
I will come
I
in.
learned more problems.
Yeah, it
Trying to
works.
get us.
You want me to walk around? Okay.
No, it works better when you do it.
Well, you're always going to have this mixture, right? All right. All right, I'll do this, okay? I'll set the first one up, and then I'll walk around and then help, okay? Caitlin, okay? Because if I do them all, you're going to be like, that's what's going to happen. When you walk out of here, you're going to be like, okay, I don't want that to happen. All right, so
It's already happening.
No, I don't want that to happen. X3 to the n, right?
Plus 100.
Plus a C note over 2 times that stuff, right?
Wait. 2
X
times x cubed over.
to the n, or to subscript n plus 25.
Is this literally just
No, this is another one.
plug the number in?
Yeah. So hold on, I'm gonna set it up and then I'll walk around, okay? So here we go.
Part of all the other problems. We just keep moving to 3.5, keep going.
That's right, I know. So x1 is 3.5. Here we go. Now, this one here, right? We're finding what value? X2. Because that, no, X subscript 2. Yeah, okay. So that means it's going to be 3.5. Now that means that's a 1 and that's a 1, right? Okay, I'm just showing the subscript, what's going to happen. Now I substitute. 3.5 times the quantity. I'm trying to read it. Okay. Yeah, 3.5 cubed plus 100, close parentheses, over 2 times 3.5 cubed
Plus 25.
plus 25. I'll make sure I write this better, okay? All right, not bad. All you're doing is plugging and chugging. That's it. And then someone will scream me to that in a second. I'm taking it.
Okay, so the top is 500.0625. That's a big number. And then the bottom is the 3.5 cubed again.
Did you get the bottom yet or not?
135.75.
What's the first one?
135 and change.
Yeah.
And what's the change?
75.
And what'd you get approximately?
And then just 2 seconds.
No problem.
This is 3.6837.
Well, it says to
Very
go to
close to
6
3.5.
decimal places.
Let's go to 6. 6
01. Or 2, 02.
O2.
Just do 02. 683702.
What is it, 500 point?
Yes.
Okay. Yep. Okay, so far, Sophia, not bad. Ms. Aber?
Yep.
All right. Now you guys generate X3. I like to just write, oh, well, this is X2. It starts looping, right? All right. You guys, I'm gonna take a motion and then I'll walk around. My head's bothering me, sorry. Mr. Upper.
So how do you fit all that in your calculator all at once? Is it
I
possible?
don't. I do the top, I write a piece, do that, and then I do the bottom. Now, you can use double use double parentheses if you want. I don't recommend it. I always do the numerator first. I stop, I write, and then I do the denominator.
Because sometimes you might not have enough parentheses and it
That's
messes
what
it
I
up.
mean. Then I'll go error, right?
Yeah.
So that's why I don't like to do everything. Now, the 88s and so on, Nick, you can do.
No. Top and then.
So you guys know if you get like a 4.9 or something, you made a boo-boo, okay? Okay, cool. Do you guys know Nick West?
Yeah.
You know, he told me that he put me in some type of whatever it was, I don't know, said I was like, I came up with 3 things, most affluent and most nerdy.